All right, so for our math workshop today, I hope everyone has copied down their assignments over from the week. Please notice that you do have a test on Friday. Friday's test will have vocabulary on it, which you will find on your notes number 1, numeric expressions. Please make sure you're studying the vocabulary. We'll review on Thursday to kind of go back over that and recap it. Y'all's quizzes that you took on Friday, I will pass those back out to you when I am here on Tuesday. Please remember the level of behavior I expect from y'all while I'm not here today. All right, let's get going on the math workshop. So for our math workshop today, we have 2/3 compared to 1/4. Remember, we're wanting to find that common denominator so they're easy to compare. So if I multiply the 4, if I multiply 3 times 4, and then the top by 4, we're going to have 2 times 4 is 8, 3 times 4 is 12. So we get 12 on the bottom. Over here, to make that 12 match, we're going to multiply by 3, and we do the top by 3. That on the top gives me 3. On the bottom, I get 12. Now it's easy to see that 8/12 is definitely greater than 3/12, which means 2/3 is definitely bigger than 1/4. All right, some of y'all could probably just logically look at those and know that 2/3 is bigger than 1/4. Number 2. So if you notice, they both have the same whole number, so that doesn't help me. We're going to have to find a common denominator here as well. Again, for 7 and 9, we can just take the 9, multiply top and bottom. Take the 7, multiply top and bottom. So now I'm going to have 3 times 9 is 27, over 7 times 9, 63. 2 times 7, 14, over 9 times 7, which is 63. Again, that makes it easy to see 27 is definitely bigger. So 2 27ths would win that battle. All right, so making sure that 2 3/7 is bigger than 2 2/9. All right, then the last one. Oh, these have the same bottom number, but this one is mixed. This one is improper. So the easiest option, let's just change this to a mixed number. 7 will go into 23 3 times, which gives me 21, which give 2 left over. So now I have 3 2/7 versus 3 1/7. Again, that first one is going to be greater than, so we ended up with greater than going all the way across the top. Please make sure that you have the work shown in your math workshop as well as your answers updated. All right, so the next thing that we need to do, guys, we are taking notes today. We need to update our table of contents. So in just a moment, you're going to get number 5. All right, and number 5, we're going to be talking about properties. All right, and we'll talk about what that means in just a moment. So right now, if you will please pause the video and pass out the notes while all of the students are copying down their table of contents. We're going to update that while the notes are being passed out. All right, so at this point, everyone should have a notes paper. Make sure that you put your name on it. Please remember that we did number this, number 5. All right, so properties. Properties are rules that are going to work for every single number. What I'm looking for is, guys, I'm going to give you the exact definition on your test. This is on your test. That is on Friday. And a property, again, it is statements. I knew there was a special word that I'd put on the test, so that's the word. Statements that are true for every, not just some, every single number. Every number out there in the whole wide world, okay? Every number. All right? And guys, you'll notice I've already filled this chart in for you, but I do want us to go over it and talk about it. The first thing I want you to notice, right here, it says addition and multiplication. Guys, circle that with your pencils. Put stars around it. Addition and multiplication. These properties only work for adding and multiplying. That's the only thing, all right? There's one property, it's called the commutative property. This allows your numbers to move. The way I remember this, and this might be a word that you've heard, it might not. The word commute. So y'all commute every single day to school. Either in the school bus you commute here, maybe it's in your parents' car. But when you commute to school, you are traveling from your house to the school. All right? What this allows to happen is it allows my numbers to travel to the other position. So like if you look at 7 plus 9, 7 traveled to the end and 9 traveled to the beginning. So they're commuting, they're moving locations, just like you move locations from your house to the school. Your parents probably commute to work every day. They go from your house to their work. All right, same thing here. You'll notice A plus B. The B moves to the front and the A moves to the back. And it also works for multiplication because all of these will work for adding and multiplying. All right, remember, what's the other way we can write our multiplication? I wrote A times B just to make sure it was clear. But remember, we also talked about how that can be AB just next to each other. So you might see that. All right, the next property is associative property. Y'all know me, I'm weird. I like to think of like normal words to help me with math words. All right, so associative property, they say they're grouping symbols that can move. All right, an associate, if you go home and ask your parents if they have any associates, they're going to tell you probably the group of people they work with. If I ask you, what are your associates? You're going to tell me the group of people that you talk to when you're at school. The key thing that I'm saying here, guys, is group. All right, the symbols that group are, and we'll kind of write this in here, parentheses. The grouping symbols can move. Guys, your parentheses are moving. So like right now, like it says 3 plus and then 9 plus 4. So right now, like 9 plus 4, they're friends, they're hanging out. But then I guess like 9 and 4, they have like a little disagreement. I'm sure you've had those with your friends before. And 9 decides, you know what? I'm going to go hang out with 3, and I'm going to be in this group. Plus, and it kind of leaves 4 out by itself, all right? So 9's a jerk, but that's okay. The important thing is that what has happened is my groups have changed. The parentheses moved. So like here, if I look at my multiplication, A times B times C. B and C are in a group. They're hanging out. They are friends. B decides, you know what? I don't want to be friends with you anymore. I'm going to go be in a group with A. A is now the associate. All right, and the C is left out by itself. So when we're doing the associative property, that's who you hang out with. That's those parentheses. That's the group. All right? The last one is our identity property. Again, it's only for adding and subtracting. So it says when adding it's adding and multiplying. Ignore what I just said. It's only when adding and multiplying. When adding or multiplying, the original number does not change. So for example, if I do 13 plus 0, is adding 13 going to change anything? So anytime you add 0, that's an identity. A plus 0. If I'm adding 0, nothing's going to change. No matter what number I put in place of A, nothing's going to change. Same thing, but when I multiply, it has to be by 1. Because if I multiply by 0, that's going to give me 0 every time. But 7 times 1, did 7 change? 7's identity is still 7. A times 1 is still A. So the identity property is something that it's not going to change. So if I came in one day and I decided to put glasses on, wearing glasses, does that change me from being Miss Sawyer? Like, I'm still Miss Sawyer, all right? So the identity is something that you can add to it or multiply times it, and it won't change it. All right?
Why do you have the letters on the bottom of the numbers? Why do you have A plus B equals B plus A? Does the A always have to be 7? Or does B always have to be 9?
Oh. Good question. So guys, right here when I'm doing this A and B, and I'm glad Ms. Donahue's here helping me clarify, okay guys? All right, this A and this B, guys, they're not related to the numbers at all. These are just completely separate examples to show you it works for numbers and it works for letters. For the algebra. All right, it works for my numbers and it's going to work for my variables in algebra. All right, because what do those variables represent? Every single time they represent a number. So here's the rule, guys. If they are true for numbers, they're going to be true for our variables since they represent them. All right, so guys, what we're going to do first, we just want to identify the property. This is kind of like a matching game. All right, so for number 1, when I look at number 1, it says 35 plus 17 plus 43, and then 35 plus, and then 17 plus 43. So you want to look at this and decide, what is it that changed? Did my numbers move? Did my grouping symbols move? Or did the original number not change? In this problem, do y'all see those parentheses? 35 and 17 were buddies, but then 17 decided, don't want to be friends with you anymore, and it became friends with 43. So that is going to be my associative property.
Make us write out the whole word every time?
Every time you've got to write the entire word. And you can hate your math teacher all night. We got to write the entire word. All right. In fact, if I really wanted to be mean, I would tell you you have to write the associative property of addition. Because right here, what's happening? We're adding. If we were multiplying, it would be the associative property of multiplication. Is there, trick question coming at you, is there an associative property of dividing?
No, because division is not add or multiply on the side.
No, because that's not adding or multiplying. All right, let's look at number 2. It says 0 plus 124 equals 124. So again, I'm looking up here. Did the numbers move? Did the grouping symbols move? Or did the original number not change? Well, if I look at that 124, did it change at all? Nope. So this is going to be the identity property. Would that be of addition or multiplication? Addition, because we're adding there. Okay. All right, next one. 20 times y times 6 equals 20 times 6 times y. So if you look here, we've got to pay attention carefully. Did the numbers move? Did the grouping symbols move? Did the original number not change? If I look closely, guys, did my original numbers change? Guys, nothing here changed at all. All right. Did my grouping symbols move? Were there any parentheses even to start with? Did the numbers move? Look at the y and the 6. Do y'all see that? My 6 moved to the center and y moved to the end. So that's going to be my commutative property of multiplication, because we're multiplying. So commutative property of multiplication. All right, last one. N times 1. Yes?
How do you spell multiplication? E-L-I-C? There you go.
Multiplication. Thank you.
Beautiful.
Okay. Y'all know my spelling ain't my best thing. All right. N times 1 equals N. N times 1 equals N. Did my numbers move? All right. 1 disappeared. It didn't move. It disappeared completely. Were there any parentheses that moved? There were none to start with. Did the original number change? So I know we're thinking of a number, but remember, what does that N, what does that variable represent? Some number. Did it change? No. So this is going to be an identity property. And this time we're going to write of multiplication because we're multiplying. Okay. Remember, if you need to pause the video, if I get to going too fast, please pause at any time. Y'all are doing an awesome job, I'm sure. The next section is going to get a little bit trickier. It's not just telling what it is. On the next section, we're going to have to determine whether the two expressions are equivalent. All right, remember, what does the word equivalent mean? Okay, that means equals. And if so, we're going to have to tell what property tells me that it's true. And if not, we're going to have to kind of explain that some more. So what this is saying on number 1, when it says 64 plus 0 and 64, the first question we have to ask ourselves is this equal? Are they equal to each other? All right. So 64 plus 0 does equal 64. So this is true. It says, if so, tell what property. So we're going to say true. Or not true. We're saying that they're equivalent. So let me Woohoo! Answer the correct question. Determine whether the expressions are equivalent. So yes, they are equivalent. All right, and the reason why, again, what property is happening here? 64 plus 0 is 64. Did 64 change at all? The 0 disappeared because this is an identity. Identity property. And that's all we're doing. If it's true, we're going to say yes and then say the property. All right, and we can again add of addition. All right, let's look at the next one. It says 8 divided by 2 and 2 divided by 8. Now, guys, I want to think about this kind of logically in our head. 8 divided by 2, we know that answer. It is 4. 2 divided by 8 is going to give me some sort of decimal or fraction because can 8 actually go into 2? It's too big. So are these two equal to each other? No, these are not equivalent. All right, so now we've got to, if not, we've got to explain. All right, so what they're trying to do is they're trying to switch the places like our commutative property does. But is there a commutative property of division? Does division work for the commutative property? No, so we're going to say commutative property doesn't work for division. And that's, again, that's using that chart that was at the top. The commutative property doesn't work for division. So, guys, if you'll notice, we're still kind of naming our properties, even if it's a no. Because we have to explain that, hey, that's dividing. It only works for adding and multiplying.
So if we just put no, we're not going to get, do we get half credit?
If you just write no, I'm going to mark it wrong because you didn't explain, and the directions clearly say to explain. You have to give me that explanation. All right, we only have a few more that we're going to look at together real quick. The next one, it says 8 plus 27 plus 52 and 8 plus 27 plus 52. So, guys, if I actually work this out, 8 plus 27 would give me 35 plus 52. And then 35 plus 52 would give me 87. All right, I'm going to work this one out in the order it says. So parentheses first. So 27 plus 52 would give me 79. And then this says 8 plus 79 now. And 8 plus 79 is 87. Are those equivalent? Is that true? Do y'all see how we're getting 87 for both of them? So yes, these are equivalent. They are equal. All right, now we've got to think about what property it was. All right, what property lets me have those parentheses in there? What property deals with the parentheses moving down? My 8 and 27 aren't friends anymore. Now it's 27 and 52 that are friends. All right, so this is going to be our associative property. All right, you can start calling all of your friends associates. You'll sound real fancy. Okay, associative property. All right, next one, it says 46 plus 15, and then 15 plus 46. If I add these together, 6 plus 5 is 11, carry my 1. 4 plus 1 is 5, plus that other one is 61. If I add these together, again, now 5 plus 6 is 11, carry my 1. 1 and 1 is 2, plus 4 is 6. They're both 61, so are these equivalent? Are these equal? Yes? What property let those switch places? What property lets you move? What property lets you travel to school every day? Okay, that's going to be that commutative property. Commutative property. So I kind of ran out of a little bit of space there. Squeezed it in. All right, last ones. 0 plus 32 and 0. Guys, I'm not going to lie. This one tricked me the first time I saw it. I was like, yep, that's true. Because I was just kind of looking at the zeros. Guys, 0 plus 32, what does that equal? 32, because your math teacher's a little goofy sometimes, okay? So 0 plus 32, this is 32. Is 32 and 0 equal to each other? No. No. So this is not true. Because 0 plus 32 equals 32 by the identity property. Guys, I'm okay if you can get me this, no, because 0 plus 32 equals 32, that's fine with me. My advanced baby darlings, I love y'all. I love this. This even specifies by the identity property. Now, y'all regular Math 6 folks, y'all know some of y'all, I expect y'all to step up. Tell me that property too, okay? This is what we're really looking for, all right? But again, if you can tell me no because 0 plus 32 is 32, I'm good with that, all right? Okay, last one. 9 minus 7 minus 5, and 9 minus 7 minus 5. Okay, so again, guys, I like to see that math. Let's actually work it out. So 9 minus 7 is 2, and 2 minus 5. Guys, have we learned how to do 2 minus 5 in here? That's a big number, so we can't do that. Let's look and see what happens to the other one. 9 minus, this has parentheses here, so 7 minus 5 is 2, and now this says 9 minus 2, which is 7. Guys, is 2 minus 5 going to equal 7? Like, there's no way. If you need to know, guys, I know some of y'all are like, what is that? Okay, 2 minus 5 would actually give me a negative 3. We're going to talk later in the year about how to find that, okay? These are not equal. 2 minus 5 is not going to be the same as 9 minus 2. You could stop right there and show that's not possible. So we're going to say, no, they're not equivalent. All right? What property was this trying to trick you with? What property were they trying to use with those parentheses moving? That's going to be that associative. Remember, that's our groups of friends. Those parentheses are associates. 9 and 7 were associates, and 7 ditched 9. So now we're going to say no. The associative property doesn't work for subtraction. Or guys, your other option is to kind of show me that work and say 2 minus 5 does not equal 9 minus 2. You can show me the math or you can name the property. All right? I'll compromise. You can show me the math or you got to show me the property. All right? Guys, I know this is something new. Use that chart. Remember, guys, on your homework, this is the first time you're doing something. You have to try it, though, to know if we're setting these up right. Your homework on the back, you're doing exactly what we did on the bottom. Tell whether they're equivalent. If they are, tell me the property. If not, explain why. Remember, for the explain why, this can be the work or the property. You can choose which one to show. Guys, you have the rest of the period to try to fill those in. Do the best you can. We're going to talk about each of them tomorrow. Oh! Big reminder. Big reminder. Make that go away. All right? Tomorrow is Tuesday. Tomorrow is the fraction decimal equivalence test. This is what you got these. You got this information 2 weeks ago. All right, I'm going to put it up here just as a reminder. Tomorrow is the test on all of these fractions and decimals. On all of these fractions and decimals. This was number 12. I gave you back those binders on Friday. All right, except for first period. All right, I have those for you today. You can get those before you leave. All right? Guys, you've got to know all of these fractions and decimals. I will give you the fraction. You will tell me the decimal. So if I say 3/10, you need to be able to automatically say 0.3. 5/9, 0.5 with a bar.
Do we have to show the bar?
You have to write that bar or else it looks like you're talking about a tenth instead of a ninth. So make sure you have the bar whenever you're talking about ninths. All right? Please make sure you study that tonight. Please get your homework done while you're in class so you have time to study that. Y'all have an awesome day. I would love to come back to awesome notes about each of my classes. Do your work. Be good.